Welcome back, everyone. We'll be going over a binary exploitation problem today. PyTime is a great question that introduces you to what position-independent executable files are. Let's quickly start our instance and download the two files provided. The source code provides us a readable format to understand the code's functionality, while the binary allows us to examine its assembly code, visualizing the software's low-level operations and memory management, which helps us identify potential vulnerabilities. The importance of PIE files lies in their memory address being randomly allocated each time they are executed. However, if a memory address is leaked, it becomes a serious issue because the difference between memory address remains consistent, granting access to the memory address of all other functions in the program. Let's now look at what the code actually does. We're given two functions. The first shows us where the main function is stored in memory and prompts us for a memory address to jump to. The second function opens flag.txt to review the flag. The goal of this problem is to find the difference between the memory address of the two functions. Once we know the difference between the two, we can use it to determine the memory address of the win function and retrieve the flag. We'll be using the binary file alongside GDB, a tool for debugging and analyzing C or C++ code. First, let's give our file execution rights, then use R and GDB to run the program, which gives us the memory address of main. Next, we use the disassembly feature to view its assembly code and search for the same address. The first line shows the exact memory address. Now, let's run this assembly again for the win function, and when calculating the difference between them, it gives us 150 in decimal or 96 in hexadecimal. We are now ready to use the given netcat command. When entered into the terminal, we need to provide the memory address we want to jump to. Based on the main function's memory address, we use the hexadecimal calculator to determine the memory address of win by subtracting the offset between them. Once we have the memory address of win, we paste it back into the terminal to review the flag. And let's see if it works. Congrats! That's it for today's episode. Remember to like and subscribe, and I'll see you all next time.